All right, it looks like we're getting some people in here. We've got our community screen up, and there we are live. Joining everybody today for the Nemotron office hours here. My name is Mark Heaps, and I am joined by the formidable, amazing, brilliant, genius Megatron man himself, Chris Alexiuk, who has been doing most of these streams with you guys. This is my first time getting to host with the legend that is Chris, talking about all things Nemotron. Chris, welcome and happy Tuesday to you, brother.
Yeah, happy Tuesday. It's great to be joined by you live for this time, Mark. So this is going to be a lot of fun. Excited to get into some questions about what we've got going on and help people understand kind of what the world of Nemotron is.
So I think, I know we do get some regular viewers. Thanks you guys for returning and joining us weekly at this time and, learning about all things Nemotron. We probably have some new folks as well. Make sure you guys stick throughout this stream so that you can get your questions asked, get your answers, see if we can help you in any way. We might do some 80s or 90s trivia as well. You just never know what's going to happen with Chris. But for those who are new, right, let's just really quickly, what is Nemotron? Because I think a lot of folks get confused about that. They know NVIDIA as, an AI ecosystem company. They obviously know the legacy of all that we've done with GPUs over the years and the great work there by all the teams. But Chris, what is Nemotron?
Yeah, I mean, it's a good question. Nemotron is our open suite of models. The keyword is open there. So that means that they're not just kind of open weights models. They're open data. They're open recipe provided through technical reports, as well as sometimes literally the code. And then, of course, beyond just being open, which is great. Totally. They're meant to be fast and really test the whole stack, right? Really, provide that efficient, capability. So it's this kind of like saying, right, that, fast models are smart models. And so that's part of the Nemotron kind of idea. But at the end of the day, they are open models, open source models, in fact.
Well, I think people get confused by this. I see a lot of folks joining the stream. I want to give a quick shout out to folks. I see folks joining from Germany. I see folks joining from India. Lots of people joining here. Thank you guys so much. I know it's really late in some parts of the planet that we all get to share. Oh, somebody even said hi to me. Hi, Abhishek. Nice to see you in the stream there. So I think there is also this part about Nemotron that maybe people don't understand. I want to touch on a few things that you said there. So one, it's this catalog of models that NVIDIA can provide, right? And sometimes people see like a llama version of Nemotron, obviously the latest stuff we've been doing with Nano. I saw someone commenting there saying, hey, it sounds like a transformer. I think he meant me calling you Megatron at that point, related to Nemotron. But how does that catalog work, right? So obviously, in some cases, we partner with groups like the model makers. But how does being in the Nemotron catalog make it different than maybe what they're providing?
Yeah, I mean, at the end of the day, right, Nemotron is about this philosophy of openness and efficiency and speed, right? So you can think of it as taking existing off-the-shelf amazing models and then kind of working them through that process. So like, for instance, with Llama Nemotron, right? Obviously, the base model is Llama. And so that's kind of locked in. And all of the work that we did to improve the model or to modify it to better suit a particular use case, all of that work is open. All of that work is available. We want to shout from the rooftops how we did it. And of course, the whole point is to take it and make it fast, right? So if you look at like Llama 405B, right? This is the 3.1 back in the day. It's a big model, and we took that and we kind of shrunk it down to 253 billion parameters, right? That's that part of the Nemotron story where we're making it fast on top of opening up everything that we did to get there.
Yeah, absolutely. And I think that's part of the way that we're trying to support the community, right, is there's all these resources to the developers. There's all these amazing model makers that are open sourcing and making open model frameworks. But what can we do to advance those by maybe using different data for training sets? But I think that's one of the unique things, and we just illustrated this with our recent release of Nano, right? Which was, it wasn't just the model and the weights itself, but you can actually gain access to that training data. And we're starting to hear stories back from developers about how just having even access to that data is enabling them to play with other models and doing fine tuning and more with that data. So I think there is some awareness that I've got to just amplify there about how cool it is that NVIDIA is sharing so much with this open model initiative.
Well, and something like, so I joined NVIDIA back in the kind of heyday of open models, right? So this is
right.
Toward the end of like the Alpaca LoRa era, and
oh man,
if you remember all the way back then, right? And seeing a company holding that mantle up, right, of open source and open research and open data is just it is so cool, because you can do you can make your own version of whatever the model we produce, right? And I think that's something that's just invaluable for, exactly like you said, people who are trying to build these models themselves, not just us, right? The whole ecosystem.
Absolutely. Researchers, data scientists, web app developers, people that have specific enterprise applications. I mean, we've just heard about so many different types of folks that are leveraging the models and leveraging the data that's available, which I think is super cool. Okay, so again, I see tons of people saying hi, and they're joining us here in the stream. Thank you guys so much for joining us. We love that you guys are here. Someone said, "Hey, what is this Nemotron Labs thing? I'm new to this chat." Well, you're in the right place, Ashray. And so let's jump off of that. Chris, where would they go if you want to maybe share a screen or something? Where would they actually go if they wanted to start playing with this themselves? And I always think, while you're pulling that up, I always think there's sort of an order to this. A lot of folks want to just be able to go to a chat interface and test their prompts out. Then all of a sudden they sort of advance from there and go right into like actually building with this, right? Accessing the models and so much more. So let's keep it real. Let's make it real. Let's actually show them where some of these capabilities are. So I'm going to ask our producer behind the scenes, Mr. Ethan, could you add Chris's screen to the stage, sir? Thank you so much. Appreciate that. Hopefully everybody out there can see this. Oh my gosh, Albus Dumbledore has joined us in the chat. I've never felt like geeking out more.
Yes. Well, this is build.nvidia.com. This is where you can find a lot of our models, and not just our models. You can find a lot of models, right? So you can see that we have Qwen 3, GPT OSS, and of course, a little guy here, NVIDIA Nemotron Nano 9B V2. And this is kind of a familiar chat interface, I would hope, at this point. Which is giving you the ability to talk to the model, right? You can ask it some pre-canned questions like the how many R's in strawberry question. You can get a little bit deeper and start asking it something real, right? And you can also play with kind of the settings. So something that's unique to this model is a little thing called min and max thinking tokens.
Right.
And that lets us choose how many thinking tokens we want to use, which is a little bit different than some other models. So, and you can play with this all in this UI. And if you're like, okay, I get it, I played with it in the UI. I've asked it to make me a pelican riding a unicycle or a bicycle. Sorry.
How many S's are in Mississippi?
That's right. Yeah.
Letters, right.
Yeah. If a parent and son are in a car crash and they, who does the operation? Classic stuff. If you want to move to the API, we provide very easy resources to move to the API, right? So for whatever system you want to use. And then not only that, but we have, of course, a fully detailed model card, which includes lots of dense technical information if you want to give that a read. And then finally, a way that you can actually deploy this thing through our NIM, right? So this is like a container that runs it on your machine, and it's going to have the settings that you need to do that. And that's kind of the idea of build, right? You can go from kind of tooling around with it all the way to actually deploying it on your local machine.
Very, very cool. And then obviously, if you were doing something like that and you were deploying there's obviously places where you can also just get the models if you want to localize it yourself. I'm seeing some questions that are starting to come in, but let me show them that real quick, and then maybe I'll call up some of these questions.
Yeah, of course. We have a Hugging Face org, and in that Hugging Face org, you're going to find lots of things related to our models. Of course, in the NVIDIA Nemotron category, you're going to see our most recent Nano 9B release. We have our Llama Nemotron collection. You're going to notice that this contains papers and data sets, right? So it's like Mark was saying earlier, it's not like just the weights. It's the data as well. It's the technical reports. And then if you want to pull this down and use it, there's instructions to do so on the model card. So you can get started with that. And one thing before we get to our first question, Mark, that I want to point out is that not only can you access it on build, but you can also access something like 9B on OpenRouter. So our friends at OpenRouter were able to get this connection ready. So if you're used to kind of that OpenRouter flow, this model is available for you to play around with there as well. So there you go. Which is
a good segue to next week. We're hoping to have a special guest join us on the live stream. A really amazing developer and founder from Hyperwrite and others called Matt Schumer, who actually converted using an OpenRouter API endpoint for one of his applications where he has a linear 50 agent sequence on improving prompt through that reasoning. And I just think those sort of architectures are demonstrating the power of these smaller language models when you add a reasoning layer into it, right? And the way that it can sort of interpret and then manage the inputs and outputs, which goes back to that control that you showed of those, how much thinking do you want in the input and output tokens? Because this is where you can start dialing in not only the quality, which I think most developers care about, but the last part that people should care about is tokens aren't free. And if you think about what that's going to do to the ROI on your application, you obviously can get better quality out of reasoning, but how much of that do you want to integrate into your application, right? Because the more it thinks, the more tokens it's generating, the more that's going to cost you and your users. So I just love that we have something where people can test so simply at build, and then think about what is the right scale there for their agents.
That's something that's interesting, right? Because I mean, listen, I gotta stump a little bit for the company line, right? But faster is smarter. And when what we're going to discuss next week in the live stream with Matt is exactly a demonstration of faster is smarter, right? The model is fast, therefore you can produce many parallel responses, therefore you can synthesize a final answer that combines all of those. And the faster you can do that, the more perk up you're going to get in terms of capability, right? So it's really true that this is a great demonstration of why faster is smart. There you go.
Absolutely. Well, I see one. Ashray put a question in here that actually says, "Is it available from pip download?"
So you can't pip download the model, but you can use something like VLLM as an inference engine for the model, which you can get through pip. Though of course we're going to recommend you use the Docker containers for this kind of workload. And so the weights themselves are available through Hugging Face's libraries. So that's the Transformers library. So you can pip download Transformers, and then from Transformers you can run the model. But the model itself is not available through pip. It's one extra leap, but it's exactly the same as any other model where you get the weights through something like Transformers or VLLM or Tensor or TLLM, and then you can get schmoving right away. Yeah.
Nice. Let's see. And I want to call out for folks that are in the stream. We're streaming to multiple social channels right now. I see questions coming in from LinkedIn. There's some people on YouTube. We love when everyone's joining us from these different spaces. So if we don't get your question answered today, just keep coming back. These topics will be covered again and again as we do our weeklies. And then we also go back to those social channels and look at comments later on. So we'll try to make sure that your question gets answered, even if it doesn't end up in the stream today. But let's see, what's another good one here that we're seeing? What somebody that just identifies as LinkedIn user. I hope I'm not sniffing a bot here. But it says, given your weights, what does the data or technical report matter? Does one need a data center to achieve a different training on the same data? Or would it even matter if you used a different loss function in training or similar? So I think there's a lot of questions in that question. Let's just get a little bit into the weights and talk about the technical reporting on the weights.
Yeah, I think I'm gonna compose this into a single
The
question.
spirit of the question.
Yes. Thank you, LinkedIn user. The idea is that, so this is a very specific recipe, right? Which means that if you follow the recipe relatively exactly, you're going to wind up with something very similar. Now, that's going to mean you use the same compute. That's going to mean that you if you want to do this in the same time frame, you've got to have a lot of GPUs laying around, right? Every recipe for a model is going to be very dependent on a number of factors. And so you can tweak it. Absolutely. I mean, we encourage you, if you think to yourself, well, this is dope, what if we use like muon clip or something, right? What if I made this adjustment and I added a layer because we're using X number of, Mamba layers or something. You want to fiddle with that. Like, you're absolutely free to, but we've only built the model through that recipe. And so you can use it as like a launch pad for experimentation. But I do want to be realistic about the amount of, compute that it would cost to do this. If you want to pre-train a model, from scratch, it's gonna cost you a lot of compute, a lot of GPUs. If you just want to if you want to take the base model, make some changes, then adjust from there, it's going to cost you significantly less compute, but the amount of stuff you can fiddle with is going to be reasonably limited compared to going from scratch. All to say, the weights exist and they map to the technical report. If you want to make changes and experiment and you have an idea that would make this better, and you work in an organization that facilitates that through hardware, then you're going to be able to make those changes and let us know, right? Like, let us know how it went.
Right. Yeah. Oh my gosh, we would love to know more about these use cases. And I should say that. So my role in NVIDIA is actually working with the developer community team, and we're always looking for people's projects to showcase, to share internally with the engineering team, the product managers, our partners, and so much more. So if you're building something amazing, if you're doing something that we should know about, especially if you're using something from Nemotron, please make sure you reach out through any of our social channels or emails, etc. Let us know, because we always want to know the cool projects that you're building and how we can get those showcased. It's always exciting to see what folks are doing with the technology. Okay, so we got a lot of other questions that are coming in here, which I love. Thanks for all the questions, guys and gals, and everyone else out there. Let's see. We've got. I'm gonna pass on the what do we think the roles of people are going to be in the industry over the next few years, because I think anyone that tells you they know what's going to happen in the AI landscape in 5 years from now is probably hallucinating themselves. It's a little bit of a wild west, and we're all inspired by it. Let's see. So someone says, you might be familiar with this, what are the best things to test on LM Studio GGUF versions? Is there a recommended workflow?
Yes, actually, we have a recent integration with Llama CPP for the GGUF versions of the model. We've done some work with them to make the performance decent, so that you're as reasonably expected, right? You can run these on a toaster or whatever, given it has enough memory.
I want that toaster.
Yeah, toaster with a RAM upgrade, right?
Yeah, give me an SRAM toaster any day.
But the idea is, like, I would test whatever you want to build, right? Like, knowing how the model performs at those levels of, say, modification or quantization, right? Which is often what's going to happen with some of these GGUF versions. Like, that's really valuable learnings and insight. And if you learn anything from it, like, please let us, again, I'm going to say it a lot, but like, let us know what you found out, right? If you say, well, actually, at the standard checkpoint quantization, we're seeing this performance, but when I try to get it down, I'm losing this capability quite a bit, or I'm running into this issue. Like, that's stuff that we want to hear and figure out from the community, like what they're trying to do. What I would say is, like, because it's a small model, so small by today's standards, 9 billion parameters for
with Nano, right?
Which is the only model that's integrated with Llama CPP at this time, is the 9B Nano model V2. I would say, like, test it with some of the stuff that we've helped produce, which is like building an agent for report generation, for agentic RAG. These use cases, I think, are where we're seeing the model perform well, up to and including at these more lightweight running environments.
Yeah, and I think that's one part of the excitement is how the smaller models are getting more powerful, especially when you start thinking about the overall architecture. Less electricity on the smaller models, less compute on the smaller models from there. Nano, just to bring that up for a second, is not a traditional transformer-based model either. Can you talk a little bit about this hybrid nature of Mamba and traditional transformer base?
Yeah. So one of the issues with so hey, attention is all you need, right? But attention is like pretty slow, honestly. It has bad scaling. Everyone's always worried about this, the scaling of attention, everything like that, right? And so what the hybrid Mamba transformer architecture does is it helps alleviate some of that attention scaling performance hit. Performance here meaning how many tokens do you get per second, right? And so what the hybrid architecture does is it replaces a lot of the traditional layers with these Mamba layers. And without kind of going down the paper rabbit hole, what this means, this blend helps to do is that at long contexts, you feel less impact from those long sequences through the attention mechanism. So it stays fast even at long context, which is something that's very important when you're talking about like a reasoning model, right? Because reasoning models aren't just like 10 tokens in, 4 tokens out anymore. It's like 30 tokens in, 7,000 tokens out, right? So it's that performance, that gain that you get over those long contexts, and people are using them for things like, hey, I'm just going to dump in my whole code base and hit infer, right? And that long context performance benefit's super helpful. Beyond that, it's fast, it's more efficient, yada yada. You get the point. But that hybrid architecture helps us deliver on the promise of faster models or smarter models.
All right, I see several questions in here, and again, thanks everybody for joining us today, sticking with us. Thanks for putting the questions in here. We really appreciate you joining us today. There was a plethora of questions just about learning about these things. So what is some of the best resources that we can offer with regards to, tutorials, building with it? I know we've got some amazing teams between whether it's the DLI courses, we've got the developer advocacy group, which builds their own videos and they place on YouTube. But where do you normally send people, Chris?
Yeah, it really depends on where you want to go and where you're coming from, right? So we like to try to make things for as many people as we can, but it still matters like how much knowledge are you coming into this with. So if you want to bring up my screen, Ethan, who's behind the scenes with us today.
Thank you, Ethan.
Thank you so much, by the way. This is our Build an Agent workshop launchable that's available through the Brev platform. And what this is it's going to take you kind of from zero to hero on how to build a report generation agent and then a RAG agent. And so if you're like, I don't know how to build with this model, I don't know how to build with models yet, this is the resource I'd point you to, along with we have many great DLI courses, of course. If you want to get started with building a model from scratch, those resources are on the way, but I would always point everybody to the best place to learn, which is our model cards, which has a lot of very detailed technical information, and also a link to the technical report. Now, I'm gonna do something a little bit cursed for a second, which is show you a technical report on screen. I'm just gonna scroll down a little bit.
My eyes.
This is everything you need to build the model. Obviously, this is not for people just getting started, but if you've been in the game for a while, that's it. Otherwise, I'd point you at this Build an Agent workshop as well. We have a reasoning model in a weekend, which is this blog produced by my colleague Marun, and it is, it does what it says on the tin, right? How to train a reasoning model in the weekend with Nemo, and there's a video. So if you're like, I'm kind of into this reasoning thing and I don't know where to get started, but I do want to get started, and I have $10 to spend on compute this weekend, this is a great resource that you can use. So that's where I'd say to get started. Another thing I'm going to say is something that I have done my whole life, which is just get started. Just start building this stuff. Use the open router endpoints, build a simple application, help, Claude Code or Cursor, have it whip up a front end for you. Just get started, right? Like, I think there's some resources that we can point you to that are great places to get started, but most importantly, just build something, and you're going to find you're able to learn relatively quickly that way, right? So
well, the great thing about this space, one of the things that I love about working in digital environments like this, though, is you're not gonna hurt anything, right? You're not gonna hurt anything at all. It's, if you start building, there's little to no risk with regards to you experiencing something, trying it out, building it from there. And again, I think you illustrated the fact that NVIDIA is trying to provide a resource where wherever you are on your journey, wherever you are in the stack as a developer, right? Whether you're an AI native working at the top who just wants to test out a library of prompts and figure out which model is best for you from the Nemotron portfolio, or if you're saying, hey, I actually want to download this, I want to try to run it locally, whatever that is, we're trying as best we can to provide resources to meet you where you are in your developer journey. And then that way you can experience it, and we hope give us feedback. Obviously, we want to continue making these things better. And so with that, you could actually join our Hugging Face. You could join our Git repos. I think we have a couple of slides that maybe show some of those addresses. We should probably bring those up. And then I just want to shout out as well. I see people in the chat answering each other's questions. Guys, we love that when you do that. Like, be the community, help each other out, support each other. Really, really love seeing that. So please keep that going. So let's see here. Which one we're going to call out first? So we got build.
Classic build. Go there to use the models. Again, if you're playing with them and you find them exciting, you want to deploy them, everything you need, the whole journey is on build. Yeah.
Someone called me out for said papers are not evil. Thanks, Josh. I agree with you. For some folks, they're a work of art. and then we've got our booming Hugging Face community.
Hugging Face is dope. So one of the things that you can do with Hugging Face that we care about and look at and try to engage with, right, is I don't know if we could do this. Maybe it's a little bit too switchy, but there's actually, for every model, there's a community tab. Right. And on that community tab, you can leave discussion threads. Right.
You want me to show you? Ethan, can you show Chris's screen real quick? I think he's showing that.
If we could get it up, that's great. Yeah. So
let's switch over to your screen and add that to the stage.
But the idea is we don't want this to be a model that's built in a silo and only we know about it and only we care about it. Right. We really want to make sure you guys have an avenue. So basically, anytime you go to one of our models, you can go to the community tab. And then you can leave comments, right? You can leave discussions. You can make PRs if you notice some documentation bugs. All of this stuff is something that we keep abreast of, that we try to make sure we're engaging with, because we really want to make sure that people, are able to engage with the model. So that's on the Hugging Face side, not just downloading the models. That's great though. But if you want to engage with the community, please do so. Yeah, we love to see people posted in these community threads.
Absolutely. Love that. And then if they wanted to connect in other ways, just have an open dialogue and an open conversation, we also have a Discord. And so we've got our slide up there now that you guys can see. I'm sending some love to Ethan here because I'm making him do producer gymnastics with all these screen changes. So we also have our Discord, and you might find Chris in there.
You will find me in there, especially if you're on if we can go back to that slide for 1 second, Ethan. I'm very sorry to make you click around so much. This is the developer Discord, NVIDIA developer. In there, we have a channel called Nemotron Models. Please join the channel. Ask any questions. In fact, this Thursday at 1 p.m. Pacific Daylight Time, we're going to have an AMA where you can ask any questions. I'll be routing those questions to the appropriate teams. Some of them will join us in the channel. The idea here is that we want to make sure you guys know, like, we're available to ask questions when you have them. You don't have to wait till Tuesdays for the live stream, right? If you've got something nagging you, just post it in the Discord. We're going to be more than happy to get to that. Yeah.
And that's another good place where you can also share your work, show the things that you want the team to be aware of in case there's a showcase opportunity there. If you're doing something really novel and interesting with blending models together in the architecture for your application, we want to know about all those things. Like, this literally is what keeps us up at night. I don't know if Chris has slept in days.
And not okay. This is something I'll just add on to that. Not just what works, guys. We want to know what doesn't work.
What doesn't work? Yeah, that's way cooler.
If you have like a problem that you ran into, like, send us the prompt response pair. Like, we want to make the models better. We'll literally, you can send us .jsonl files filled with your experiments, right? Like, this is, we want this to be something that we're building together with the community of developers who are using it every day or every other day, I guess. Yeah.
Absolutely. And then, of course, if you do have projects and you want to, reach out to us, you can also do that via the email address here, community@nvidia.com. That goes into our team so that, send us whatever links you've got, send us whatever features you got. And even if it's not your project, I always say this, if you know a group that's doing something really interesting, you guys are the pulse within the community. So if you see something, you're like, wow, that was a really amazing build. I'd never seen anything like that. You found out someone was using Nemotron or specifically Nano, because we're really passionate about Nano right now. Email that over to us and let us know what it is. It's a great way for us to stay informed, with you as the community. So let's see, Chris, I see you've got some links that you were maybe putting in the chat or sharing there for people. So hopefully everyone can see that in the chat, because a few folks have actually asked about that. Let's see. I'm trying to find maybe a couple more questions.
Before you do.
Okay, you do that.
I got it. I got a shout out GTC DC, which is the funnest DC to say by a country mile. So we'll be at GTC DC near the end of October. I'll be there in person. So if you're in the DC area or making the trip out, hit me up at a session, or if you see me roaming the hallway. We're going to be talking a lot about not just Nemotron, but the whole cavalcade of AI ecosystem that we have at NVIDIA, answering your guys' questions, trying to learn what you've been doing with these tools and what makes your experience with these tools excellent. So come on down to GTC DC and we'll see you there. Yeah.
And I'll double on that our team is also putting on a hackathon during GTC DC, where one of the prize tracks is best use of Nano in the Nemotron catalog. So, if you're familiar with the model and you're attending and you want to build something and blow people away, there's so many folks there to be able to see the great work during the hackathon. So feel free to come on down and join us for that. Well, I know we're getting close to time. I'm going to take, I think, one more question. And I think this is a good one because it's a very high level question for ways of interpreting usage. I'll put this one on screen, Ethan. I got the button. It says, and Matt Ferraz, thanks for putting this in. He says, I'm working on creating a project with Nemotron and I keep running into errors where the model is being too verbose and won't give a direct answer. How can I improve my system prompting? And I think we've all run into this. Like, there are times when the model is way too praiseful and it's like, what an excellent question. Thank you for asking that so much, my excellent friend. And it just keeps on going on and on. Sometimes it's just not succinct enough. So what's your advice here, Chris? Because I've seen folks do this through sysprompt instruction. I've seen people do this with the temperature settings to try to get that to not be too creative. When you think about this particular set of models, because NVIDIA has adapted them to be in Nemotron, where do you normally direct people?
Yeah, I mean, we're going to have some resources coming on this, number one, so you can look forward to those by GTC DC timeline.
Cool.
Number two, especially with something like Nano, right? We have a direct access to like the maximum number of reasoning tokens, which can help us keep our responses less verbose. We also have the ability to use like no think mode, so we can actually make reasoning tokens literally zero. In terms of like verbosity of response post reasoning, that's going to be something that you're going to want to kind of fine schliff through the actual system prompting. We've seen people use libraries like DSPy to help with this, right? So to reduce that verbosity. You can also, this is like the nuclear option, right? But you can also fine tune the model to be less verbose, right? The very nuclear option. But all of these strategies, like I would recommend, Nano does well with a short list of extraordinarily focused instructions. And so I would keep my instruction list very short and extremely to the point. Don't inject pleasantries into the system prompt. You're just going to encourage the model to do so. Verbosity will go up. Yeah, but depending on the task, you can get away with like 2K reasoning tokens max, right? And so that's going to help limit things and hopefully keep the model a little bit more to the point. And then, of course, last kind of option here, depending on the inference solution you're using, you can also ask it to output in a specific format, and hopefully that format encourages less verbosity.
But this is the cool part about using these smaller models, because what might have been in the past, you use a 7 dB or a 9 dB or an even bigger model, and you're sort of hoping for the best of the reasoning in that one capability. Imagine now being able to take a 9B model with reasoning capabilities and having contextually unique sys prompts in each version of that as an agent, where they're arguing with themselves to get you that best result. And I just love the amount of levers you can create while keeping that cost down, because you've got that smaller model, right? Whereas if it's a 9 dB model and you do that in layers, you're more than 10xing the cost. So I think the adaptability, what we're seeing with attention, what we're seeing with scale, it's just a great time to be playing with these new models.
And if you find the system prompt that works really well for you, or the solution that works really well with you, share it on Discord, share it with the community, share it with other people building, right? Like this is, again, we want to make sure that we're helping people understand how to best use these models, and some of that is going to be directly from you guys, right? Like just playing with it, understanding it, and sharing those resources back to the community. Yeah, absolutely.
So, well, yeah, and I see some more comments from the community about how they're getting better results out of the prompts. I see things like loop detection mechanisms, dynamic context pruning. There's so much good stuff out there. So it looks like we found our tribe. We found our people. Thank you for sticking with us throughout. Join us next Tuesday. It probably won't be me. It very likely will be Chris. But we love this, and we want to keep the conversation going. The amazing Matt Schumer will be here hopefully next Tuesday, talking about some of the projects he's building and talking about these agentic workflows with these different scales of models. But I think we're a little over time, and this is probably a pretty good spot to cut, Chris. So good with you?
Good with me, guys. Keep the questions coming on Discord. I'll be there during most times. So there you go.
And hopefully we will see you at, and I'm going to put it up on the screen, we will see you maybe at GTC DC, or at the very least, we'll see you at streams in the future. So thanks, everybody. Have a great rest of your Tuesday, and we'll chat again soon. Thanks so much, everybody. Appreciate you.